Hello and welcome to Better Geology. I'm Andrew Dunning, and this is my first week of fieldwork for the summer. If you've been watching the rest of this series, then you know that it's time for me to do my fieldwork to begin investigation of this recently discovered fault. I've actually already been out here for a couple of days, but because of timing and the amount of work we've had to do, the process has been slow and I haven't had time to make a video until this day. Primarily, we've been studying the glacial moraines that are offset by the fault in order to better understand the glacial history of the Strawberry Mountains. The glacial history is going to be important for understanding long-term slip rate along the fault. Some of these moraine crests are observed to have fault scarp offsets of more than 1 to 2 meters, which suggests that more than one earthquake has occurred across that moraine over time. A big part of this process is cosmogenic radionuclide dating using helium-3 trapped in pyroxene crystals within the andesite boulders and lavas found in these glacial deposits. So as the glaciers came down out of the mountains and scooped out rocks from these big stacks of andesite lava flows, these blocks got dropped in big piles on either side of the glacier called a moraine. The boulders on the tops of these moraines have been exposed to the sky more or less since they were originally deposited, and this means they are an excellent proxy for understanding the age of the glacial features. If we find out a glacial moraine is, for example, 23,000 years old and it has 4 meters of offset across the fault, that means that this fault has moved about 4 meters in that 23,000 year period. And that's why the glacial story is important in this area. Even though I'm not a glacial geologist, having an understanding of the glacial chronology is going to be very important for understanding the fault and its behavior. I've also talked a lot about carbon-14 dating for some of these earthquake deposits, like we did at the Gate Creek Trench project. But as of this trip, we haven't had time to dedicate on that. I'm hoping to scout some locations later today, and I will definitely record that when we do. So this whole trip so far, we've been walking along the crest of these moraines, and we've made it up here to the top of this one on the east side of Slide Creek. And this is the highest elevation and probably the oldest moraine in the vicinity. And I'll show some of the topography LiDAR pictures of it right here, so that you can see why I think that, because it's very high and the crest is very broad and eroded. And what I'm sitting on right here is a boulder. And for the radionuclide sampling, we need to find boulders that have been undisturbed since the glacier dropped them here. So my current thinking is that this moraine is about 100 to 120,000 years old, just based on some other research elsewhere in Oregon. But in order to prove that, we need to find boulders to date. And boulders this size, this one's a little over 1 meter across on both dimensions, and that's of a size where I'm confident in saying this probably hasn't moved in 100,000 years, and it's pretty close to the top of the moraine, so this is a good candidate for sampling. We're not going to sample today, but all through this exploration we are dropping marks with a GPS point so I can return to them later in the season and collect samples all at once. So what I've got here is a Trimble GPS. This is a very high precision GPS used for this kind of work. You get an accuracy down to the centimeter level, which is what you need when you're locating boulders in a dense forest like this one. So when we find a boulder like this, we measure it, we look at it, and I take a GPS point and I write everything I can think about it in my notes. I've got notes here from every boulder we've looked at. This is our 5th one today. We're hoping to find at least 10. And at the head of this moraine, we will intercept the fault scarp. We already visited the fault scarp on Thursday on a different moraine, and it's going to be really important to visit this one because this moraine is considerably older. And analyzing the difference between the fault displacement on the young moraine and on the old moraine is going to be helpful for understanding the long-term behavior of this fault. So I'm up here now. We've made it all the way to the head of the big moraine, and I'm basically standing on the fault scarp here. It's actually about 10 feet further up the hill, but there's not much to see here. And this happens sometimes in this field of science where something looks really good on the LiDAR imagery, and then you get your feet on the ground and it's covered in dead trees, and the scarp itself is fairly eroded. There's not much left. And that's the case here. So the investigation that we did, just sort of looking around up here, revealed that the head of the glacier ends pretty much at the fault scarp itself, maybe a little ways below. There's not many rocks around right here to give a good idea of exactly where that boundary is. But either way, there is bedrock above the fault. So that means that this was a topographic prominence when the moraine was being formed. So overall, it's been a good day, and we're going to sample 1 or 2 boulders on our way back down, and it's been very productive. So it's day 5 here of our fieldwork trip, and my trusty field assistant Kate Hederick and I are pretty wiped out. Nevertheless, the work continues, and we're here sort of revisiting an area we visited a couple of days ago with research advisor Dr. Ashley Strige. We're here on this sort of little tiny moraine here, which has a little bit of a confusing geometry. So we're currently standing about right here. And because I have the contour lines turned on for this map, you can see how this moraine geometry dips here. And we expect glacial moraines to be relatively continuous in slope, but we're much higher than we are right here. This map is nice because you can see the fault scarp right here, which is, of course, the target of this study. There's a nice offset stream terrace here. But getting in here to study how the fault interacts with the moraine crest is the primary goal for today, as well as looking at this here. This is a faint recessional lateral moraine from a later glacial period. So that's what we're doing today. I'm not really sure what we'll find up here. It could be heavily vegetated again and nearly impossible to see anything interesting, or it might be beautiful like we saw on our first day here. Behind me, you can see in the Strawberry Mountains themselves, a lot of it is very clear. You can see the individual lava flow strata very clearly in a lot of places, as well as the glacial morphology, these big U-shaped valleys and sharp peaks, which are very characteristic of glaciated areas. So I'm standing now on that lateral recessional moraine that I mentioned earlier. And I'm actually surprised how much I can see. I'm standing on the top of the fault scarp right now, and you can probably see it sloping away slightly to this side of me. Based on where it is here, this is uplifted about, I think about 2 meters, between 2 and 3 meters is my estimate. I'll have to verify that on the LiDAR when I get back to the lab. So since I'm standing on the fault scarp here, I will now smash cut to being at the top of the fault scarp on the moraine. So this is what the top of the moraine crest looks like where the fault crosses it. Behind me there's about 5 meters of vertical offset. And that tells us that the fault right here is really complex during earthquakes. About 100 feet that way, what I'm interpreting as the most recent earthquake scarp is about 1.25 meters. So a little over 3.5 to 4 feet. But this is much bigger, so that reflects that more than one earthquake has offset this part of the moraine. I'm about to go look for boulders at the top of this moraine so that we have some to compare to the rest of the moraine to make sure that the uplifted part of the moraine and the lower part of the moraine are the same age. I'm not going to video any of that because it's starting to get late in the day and we need to really get moving.